All right, Algebra 1, we are on our last week before spring break. We're going to be going through two different parts of Chapter 8 with factoring, and then move on to spring break and continue factoring after spring break. So the first thing is factoring is basically this backwards. So what we're going to do as a warm-up is these three problems. So if you need to pause the screen, go ahead and do so now and try those. And let's see what we got for these. So the first one, I needed to, distribute the A. So what we ended up with was 3a squared plus 7a. And then same thing on the next one, negative 2m times everything. Keep in mind your sign, so negative 2m to the third, negative 12m squared. Negative times negative is positive 2m. And then the last one, we had 4x to the third times both, so 4x to the third, and then 4x squared, we get 4x to the fifth. And then y didn't change. 4 times negative 2 is negative 8. X to the third didn't change, but y times y is y squared. Okay, so factoring is basically what we're doing is backwards from what we just did. So we're going to break up a polynomial into its components. Okay, so what that means is when I have something in simplest form like 3x plus, let's say 3x squared plus 15x, I'm breaking it into its factored form by saying, okay, well, what do both of these divide by? 3 and an x. And so I'm basically taking out the 3x by dividing. And so 3x is on the outside. Now I have 3 divided by 3 is 1. And then 1x left. X squared over x, 2 minus 1. And then 15 divided by 3 is 5. X divided by x cancels. So it's just there. And that's factored form. Okay? So whatever you can take out of the parentheses, and then the parentheses that is left over. Okay? And then any polynomials that cannot be factored are called prime. Okay? So, factoring out a GCF, a greatest common factor is the greatest number that can divide everything in the polynomial. So check the coefficients first for a GCF. So, for instance, there our GCF was 3. And then look at the variables. A variable must be present in all of the terms to be a GCF. Okay? If a variable is present in all terms, take the lowest amount of things. So it's like saying if everything has at least 2, you're going to take 2 out, not anymore. Okay? So divide each term by the GCF and leave the remaining in parentheses. So let's look at a couple here. So I look at 3 and 12 in this case. Both of those can divide by 3. And then x is only in the first one, so I can't actually divide by an x. So 3 goes to the outside, and then I divide to get what's in the inside. So 3 divided by 3 is 1, with an x left over, plus 12 divided by 3 is 4. And I double check, make sure there's nothing else I can divide, and I'm done. Okay, so number 3, kind of the same deal. If I'm thinking, okay, 8, does 8 divide 36? Well, let's see. 36 divided by 8. Okay, not in this case. So, what else can divide by 8? 4. And 4 actually does divide 36. That's the greatest common factor. Okay, and then m and n are different, so I can actually take that out. So 4 is on the outside. 8 divided by 4 is 2 with an m. 36 divided by 4 is 9 with an n. And there we go. Nothing else I can do there. Double check, make sure you can't divide those by anything. And if not, you're done. Okay? And so same thing on number 2. Both of these can divide by 7 and nothing else. So 7 on the outside. 7 divided by 7 is 1 with a y. And then minus 7 divided by 7 is also 1. There we go. Okay, so let's go to the back side, look at a few of those. And in this case, let's look at number 6 and 8. So in this case, 4 and 24. So start with 4. Does 24 divided by 4? Yes. And they both have at least one y. So 4y is my GCF. And then let's divide. 4 divided by 4 is 1. Y squared and y, 2 minus 1 is 1. So y minus 24 divided by 4 is 6. Y divided by y cancels. And we're done. Okay, same thing on number 8. 14 and 18 both divide by 2, and they both have an h. They both don't have a g, though, so I got to leave the g there. So 2h on the outside. 14 divided by 2 is 7, with a g left over, no h's. Minus 18 divided by 2 is 9, with an h canceled, nothing left over. There we go. Okay. And so let's look at 11 and 13 here. Number 11, these don't have any numbers, but I can divide both of them by an a. So a goes to the outside. A divided by a cancels. I have b left over. Now, this part can be a little tricky sometimes if you're not careful. So a divided by a is not 0. It's actually minus 1. There is still a 1 there. 1 divided by 1 is 1. Okay, so now number 13, we've got 13, 5 and 13 don't have anything we can divide both by. X and Y are different. And so this one is one of those prime ones. Can't do anything. It's called prime. Okay, so let's look at the 14 and 16 here. Number 14 can be a little tough because both numbers are pretty big. So 18... Thinking 18, 48 divided by 18 is a decimal. Okay, that's not going to work. What other 18 factors do I have? Well, in this case, if you can't think of it, what you can do is say, okay, well, both are even, so I can divide by 2. This is just in a case where you can't think of the GCF. Divide by what you do know. So 2, and then both have at least one A. Both have at least one B. Both have at least 2 C's. Okay, so A, B, C squared. So 2ABC squared. 18 divided by 2 is 9. With an A left over. B's cancel. C's cancel. Minus 48 divided by 2 is 24. A's cancel. B's cancel. 1 C left over. And so normally I'd be done, but I didn't take the GCF, the greatest common factor. So I'd double check and say, okay, 9 and 24 both can divide by 3. So I take the 3 out with the 2. So 3 times 2 is now 6 ABC squared, and then just divide the numbers. So 9 divided by 3 is 3A. 24 divided by 3 is 8C, and that's it. Okay. And so let's look at one more here. Number 16 is fine. Let's do that one. So 9, 18, 24, both all can divide by 3. These two can divide by 9, but 24 cannot, so I can't do 9. And then all of them have at least one R, but the first one doesn't have an S, so I can't take out an S. So 3R on the outside. 9 divided by 3 is 3. R to the 8 minus 1 is 7. Minus 18 divided by 3 is 6. R left over, S left over. And then 24 divided by 3 is 8. R cancels, but I have S squared left over. And there we go. Double check your numbers. They all cannot divide by something, so there's my answer. Okay, that's it. If you want to see any more examples, there's a Khan Academy that goes through that pretty nicely, or you can ask me any questions you might have. Okay, peace.